Okay, I'm going to try to walk you through the problem that's on page 538. Now let's just say that I have a potato chip factory and I'm going to buy potatoes. This is my main supplier, okay? This is me. I'm looking at the potatoes. This is the farmer. He's selling these potatoes. Now this guy tells me that there are no more than 8% of these potatoes are bad, and I'm looking at these things. So I'm going to start out with this. I'm going to get a null hypothesis and an alternative hypothesis. So my null hypothesis is that there's no change. Yes, if I test this thing, I'm going to get a proportion of around 8% bad potatoes. Versus my alternative hypothesis, which is what I want to try to prove, because I don't want to get ripped off, is that the proportion of potatoes that are bad is much higher than 8%. Now here's the real question. What is the proportion of potatoes that are bad that I would need to actually reject the shipment? Is it 9%? Is it 8.5? Is it 9.5% in my sample? That I would say I don't think that now if I got like 20% bad potatoes, 1 out of 5 potatoes was bad, I might say, you know what, I'm going to send this truckload back. If I make a mistake and send this truckload back and they're actually good, it costs me a lot of money. So I don't want to make a mistake. Well, let's do an alpha level. That's where that comes in. So my alpha level is 0.05, and I got to figure out how high would this sample have to be in order for it to, like, just say it's 9%, only would happen 5% of the time or less. That would indicate that more of these potatoes are bad. If I just, it's kind of like, did I get that unlucky? Remember the free throw shooter? He had that bad of a day that it would only happen that, like it only had a 5% chance of happening. So that's that alpha level. But now we got to figure out, well, what is that? If we take a sample, what is it that we need to do? Well, let's just say that we sample 500 potatoes. So n is, so our sample size is going to be 500. Well, you know where I'm going to go with this, right? Well, I'm going to say, since it's an unbiased estimator, that my if I was to do this over and over and over again, right, I would suspect that it would be u of p hat would be about 0.08, like that. Now I'm going to do the standard deviation, and you know what that's going to be. It's going to be 0.08 times 0.92 divided by sample size and the square root. And what do we get for that? 0.0121. There's my standard deviation. Okay. So here we are up here at our 5%, right? So if we get a sample that's in this area, we're going to say, well, the probability of that happening is too low. We think that more of these potatoes are bad. Okay, so what is that number? Well, that's 5%, right? So if we do inverse norm of 0.95, right, that's that place, the inverse norm gives us 1.65. 1.65. We're 1.65 standard deviations above the middle to get to that 95 place. Okay, so here we go. So what I do is I take 0.08, right? 0.08, so that's what I think it's going to be. I'm going to add 1.65 times my standard deviation, which is 0.0121. And what I get for this is, that should equal, it's like 0.099999, so it's basically 0.10, okay? So that's my cutoff point. That's where I am right here, at this spot. So I say, if I take a sample and I get 10% or more bad potatoes, I think that there's a problem with this truckload of potatoes up here, okay? So there's that. Now there are two types of errors we can make. We can make a type 1 and a type 2. So the type 1 is, so type 1 error is when you just happen to get a bad batch of potatoes, right? So you get this sample that's up here, but actually this is true. It's really 0.08, but you made a mistake because you got a bad batch. So if you're up in here, you're going to reject this truckload of potatoes, okay? So that's when you reject HO, right? You reject the null hypothesis even though it's true. That's a mistake. That means, in this case, if we rejected the truckload of potatoes but they were still good, that costs us a lot of time. We would have to send the potatoes back and get a new truckload of potatoes, and maybe get that farmer kind of mad at us, and maybe not want to do business with us again. So they always ask us, what is the type 1 error and what is the consequence? Now, here's the type 2 error. The type 2 error is we took a sample and it actually looked good. So we fail to reject the null hypothesis and we keep that truckload of potatoes, even though they're bad. So the type 2 error is we do not reject the null hypothesis, even though it was false, meaning we kept a truckload of potatoes that probably had more potatoes bad than 8%. Okay, so what's the consequence of that? Well, we're going to get a lot of those nasty green potato chips, you know. Um, so, and which one is more costly? Well, I think if we keep a full truckload of bad potatoes, that's more costly to us than the other one. So, and it really depends on the situation, each problem. Which one is worse, the type 1 or the type 2? So that's what we're going to talk about tomorrow. And if you watch this video, which you are, obviously, if you're listening to this, I think it's really going to help things go a little bit smoother. Anyway, happy Pi Day.